Okay, a couple more examples and we'll get to Bayes' formula. Let's say a box has 7 red balls and 3 white balls, and a second box has 6 red balls and 4 white balls. And let's say a pair of dice are tossed. If the sum of the dice are less than 5, a ball is selected from the first box. Otherwise, it's selected from the second box. Find the probability of getting a red ball. So we want the probability of red. So let's look at our branches. Alright, so B1 tells us the ball we're going to select from box 1. And less than 5 would be if the sum of the dice are less than 5. Well, if you think about it, there's 6 ways we can be less than 5. You can roll a 1-1, a 2-1, a 1-2, a 1-3, a 3-1, or a 2-2. So there's 1, 2, 3, 4, 5, 6 ways to get a sum less than 5. So the probability that we select from box 1 is 1/6. Now, otherwise from box 2, well, if the probability from selecting box 1 is 1/6, then just subtract 1/6 from 1, and you get that the probability of selecting from box 2 would be 5/6. Okay, now let's look at the second branches. If we select from box 1, we'll get a red ball with a probability 7 out of 10 because there's 7 out of 10 red balls. And we'll get a white ball with a probability 3 out of 10. If we select from box 2, we'll get a red ball with a probability 6 out of 10, but I reduced it to 3/5. And the white ball will be the probability of 4 out of 10, which reduces to 2/5. Okay, now, so my answer here, what's the probability of red? Well, remember the probability of red, you figure out all the ways to get red. So one way to get red is box 1 and red. So to get box 1 and red, we just multiply these two together, 1/6 and 7/10. So we have 1/6 times 7/10, and that's the probability of box 1 and red. Now if we want to get the other way to get red is to go box 2 and red, and so if we multiply those together, 5/6 times 3/5, we get this. Now if we work this out, this is 7 over 60 plus 15 over 30, which is 7/60 plus 30/60, or 37 out of 60, or approximately 0.617. Now, so that's the probability of getting a red ball. Now, if we want to know the probability of getting a white ball, then all we have to do is subtract this from 1. But if you want to do it the same way I did this, you could. A white ball, you would say 1/6 times 3/10 plus 5/6 times 2/5, because there's only 2 ways you can get a white ball: box 1 and white, or box 2 and white. So box 1 in white is 1/20. Box 2 in white, multiply that together, you get 1/3. Add 1/20 to 1/3, and you actually get, if you put it in a calculator, you get 0.383. So the conclusion here is we can easily calculate the probability of a later event, such as red, given the probability of an earlier event, such as box 1. Because, see, these are conditional probabilities. This is not the probability of red. Remember, the probability of red is 0.617. This is actually the probability of red given box 1. In other words, given that we selected from box 1. And this is the probability of red given that we selected from box 2. So that's different than just the probability of red. So keep that in mind. Okay, now I'm going to show you how to calculate the probability of an earlier event given the probability of a later event. So what if I said, what is the probability the box came from box 1 given that it was red? See here, I know the probability that it's red given that it came from box 1 is 7/10. But what's the probability it came from box 1 given that it's red? That's a little more complicated. Okay, so that's where we have to bring in Bayes' formula. Okay, so we'll get to it in a minute, but I'm going to show you how to find the probability of box 1 given red. All right, so remember, we have this formula: the probability A given B is the probability A intersect B over the probability B. Now let's write the formula using B1 and R instead of A and B. So the probability of box 1 given R would be the probability of box 1 intersect R over the probability of R. Now recall that the probability of box 1 intersect R can be written as the probability R times the probability of box 1 given R, or it can be written as the probability of box 1 times the probability of R given box 1. Since we don't know the probability of box 1 given R, that's actually what we're looking for, we're going to use the second formula because we know the probability of red given box 1. So to get the probability of B1 intersect R, we're going to use this: probability of B1 times the probability of R given B1. So putting it all together here, the probability of B1 intersect R, remember that was what we had up here, is the probability of B1 times the probability of R given B1 over the probability of R. Now, we know how to get the probability of R. We did that up there. So now, all I have to do is say, okay, what's the probability of, to finish this out, what's the probability of box 1? So the probability of box 1 was 1/6, okay, and then multiply it by the probability of red given box 1. Well, the probability of red given box 1 was 7/10, and then on the bottom I have to find the probability of red, and remember, probability of red, I had to multiply the paths that took me to red, 1/6 times 7/10 and 5/6 times 3/5, and I added them together, so that's the denominator. And when I did all this together, I got 7/60 out of 37/60, which reduces to 7/37, or about 0.189. Now, there is a quicker approach to this, because there's a pattern to this. Really, if you'll think about what I did, all I did up here to get the probability of box 1 given R, all I did is I took the product of the path from box 1 to R, right? See, I took box 1, 1/6 to R. So I took 1/6 times 7/10, and that was on the top, right? And then on the bottom, I summed all products that lead to R. So I do 1/6 times R plus 5/6 times R and add them together on the bottom. So basically, by following that route, that's the simplified form of Bayes' formula. So B1 to R here, and then all paths to R on bottom. There's 2 paths to R. Okay, and then just simplify the math. Now let's try it for box 2 given red. Box 2 given red. Let's see if we can do that. Well, for box 2 given red, then the top should be the path from box 2 to red. So that would be from here to here, right? So that would be 5/6 times 3/5. So there that is. And then all paths to red will be on bottom. So the 1/6 times 7/10 and the 5/6 times the 3/5 will be on bottom. And then I'll add them together. Now, if you'll notice, this is the probability of box 1 given R. This is the probability of box 2 given R. Notice that if you add them together, you get 1. Which they should be, because they're actually complements of one another. So you can freeze it here and read, this is basically the Bayes formula I gave you there. Independence is important. This talks about independence of events, but go ahead and read this on how to determine if 2 events are independent. But for 2 events to be independent, the probability of their intersection must equal the product of their probabilities. So that's basically independent events. So you can freeze the video and read that if you want to. Let me go ahead and show you some examples here. let's say that one urn has 4 red balls and 1 white ball. Second urn has 2 red balls and 3 white balls. A single card is drawn from a deck. If the card is less than 5, a ball is drawn from the first urn. Otherwise, a ball is drawn from the second urn. If the ball is red, what is the probability it came from the second urn? Well, let's say U1 is selecting from the first urn, U2 is selecting from the urn 2, and let's say R is that red is selected. So we're saying we're given that the ball is red, and we're asked for the probability that it came from urn 2. So we want the probability of urn 2 given that it's red. So the probability tree helps here. If you check the cards, there's 4 cards. There's actually 16 cards that are less than 5. Ace, 2, 3, and 4. And 16 out of 52 reduces to 4/13. That means there's 36 cards that are 5 or greater. So that reduces 36 out of 52 reduces to 9/13. So the probability you select from urn 1 is 4/13. The probability you select from urn 2 is 9/13. Now, given that you selected from urn 1, since there's 4 red balls in urn 1, your probability of red is 4/5 and your probability of white would be 1/5. Now, given you selected from urn 2, the probability of red is 2/5, the probability of white is 3/5 because there's 2 red balls and 3 white balls. Now, so to find the probability of urn 2 given red, you just say multiply urn 2 branch times the red branch, so 9/13 times 2/5, and there's that. And then you find all paths to red, so you take 4/13 times 4/5, and I put that there, doesn't matter if you put it first or last. And then the other path, 9/13 times 2/5 is the other path to red, and then you add those two together. And so I get 18 out of 65 over 34 out of 65, which is 18 out of 34, or 0.53 here. Okay, so that's the answer to that one. Okay, I'm going to jump ahead to number 3 here. It's actually numbered wrong. It says 5, but it's actually the third example. A basketball team is going to play 2 games in a tournament. The probability of winning the first game is 0.10. If the first game is won, the probability of winning the second game is 0.15. If the first game is lost, the probability of winning the second game is 0.25. What is the probability the first game is won? So we want to know the probability that we win number 1 if we lose 2. So win 1 given we lost 2. So probability that we won the first game given that we lost the second game. Well, we know if you look up here, we know that the probability that we win the first game is given as 0.1, so the probability we lose the first game is 0.9. Probability we win the second game, given we won the first game, is 0.15, so the probability we lose the second game, given that we won the first game, is 0.85. It also tells us the probability we win the second game, given we lost the first game, is 0.25, so that means the probability that we lost the second game, given that we lost the first game, is 0.75. So now to find the probability of win 1, lose 2, basically what we have to do is find win 1, lose 2 first. Win 1, lose 2, so that's 0.1 times 0.85, so there that is. And then all paths to lose 2 go to the bottom. So win 1, lose 2, 0.1, 0.85 goes here, and then lose 1, lose 2, so that's 0.9 times 0.75 goes here. We add those two together, and then we divide it into the numerator, and we get 0.112. So the probability that they won game 1, given that they lost game 2, is about 11%, 0.112. Okay, I'm going to leave you with telling you to just freeze the page and look at number 2 and read through it and draw the diagram. Then go down here, look at this example, this number 5, the one with Hansen's disease, and then draw the diagram and work through it. And then finally, I'm going to slowly scroll through here to the tuberculosis screening, and you can see it. And that's pretty much it on probability.